Chapter 3, Lesson 5, Graphing a Line Using Intercepts. So first of all, we might even want to talk about what an intercept is. So let's look at this for just a second. Bring up a graph. So if I'm talking about the intercept of, let's do this line right here. So if I'm talking about intercept, it has an x-intercept and a y-intercept. So an intercept is just what it says. It's where it intercepts, or where it crosses the x and y axis. So remember that the horizontal axis is the x. So where does this line cross the x? Right there. And that is -1, -2. So the x-intercept is -2. So you just simply write x-intercept equals -2. Where does it cross the y? Right there. It crosses the y, which is vertical. Crosses the y right there at +2. So the x-intercept is -2. The y-intercept is +2. Now, they could give you, if you knew the intercepts, you would be able to graph a line just from those 2 points. So let's say that the x-intercept equals -6, and that the y-intercept is equal to 4. You should be able to take those 2 points and graph a line. So if the x-intercept is -6, that means you go to -6 on the x, right there, count over, 1, 2, 3, 4, 5, 6. That's a point. The y-intercept is 4, so that means it's going to cross this y at 4. 1, 2, 3, 4. Between those 2 points, now you would need to take a ruler. Since I don't really have a ruler option on the smartboard to draw a straight line, I'm just going to do it this way. You would take and draw a line through those points. Okay, that is how you would graph using an intercept. Once you know those, you can just simply put them on the x and the y axis, draw a line that connects them, make sure you extend it, and make sure that you have arrows on the ends of your line. Okay? So let's remove this line, so that way we've got it for next time. So let's remove that line. We'll remove our text that we had up there. Now let's go back to the book here for just a second. All right, so the x-intercept of a line is the x-coordinate of the point where the graph crosses the x. That's what we just did. Shortened version, where does it touch the x? Since the linear equation can be graphed using 2 points, you can use the x and y intercepts to graph, which we just did. See how far advanced we are. Prodigies. All right, example, state the x and y intercepts of y equals 1.5x minus 9, then use the intercepts to graph the equation. Now, think about, for just a second, whenever we had this back here, which I already erased my line, but that's all right. Let's do this one and this one. Okay? What are the coordinates of those intercepts? If this was my line, which I'm just going to freehand one in there just for a second. And no, it's not perfect, but just for point's sake, what is the coordinates of that point right there? It is 0, 0, and the y-coordinate 2. So the y-intercept, is 0, 2. Now, for the x-intercept, the x is -4. The y, the up and down, is 0. So the coordinates of this point right here, which is the x-intercept, is 4, 0. So here's what I want you to notice. If it is the y-intercept, the x-coordinate is 0 because you're right on line. X is 0. If it is the x-intercept, your y is 0 because it's right here on the line. That's where it crosses. Where it's at the line, that coordinate is 0. So going back to the book, if it says find the intercepts, we just said, now this is something that you might want to put in your notes. To find the x-intercept, you have to put in 0 for y. To find the y intercept, you have to put in a 0 for x. Now, you only do them one at a time, so don't go putting zeros in for everything because it's not really going to make sense to you. So if this is our equation, y equals 1.5x minus 9. Does not matter which one you do first, but let's say we're going to do this one. We're going to do the x-intercept. For the x-intercept, we're going to put a 0 in for y, which means we are going to replace that with a 0. The rest of it stays there, 1.5x minus 9. Solve it, we would add 9. Those 9s don't really look like 9s, but I promise they are. All right, that crosses out. Right side we have 1.5x. Left side we have 9. So divide both sides by 1.5. Divide both sides by 1.5. That crosses out. On the right-hand side we have an x. On the left we have 9 divided by 1.5, which happens to go in there. What would that be? 9. I'm about to sneeze and I'm trying not to. So they go into 3, 2 times, so 6. Just a little mental math there. So for the for the x-intercept, the x-intercept is what we found right here. X-intercept is 6. So what are the coordinates of that? If we know that x is 6, what do we put in for y? A 0. So that is my x-intercept. X-intercept is 6, 0. Now, let's go back and do the y-intercept. So to do the y-intercept, it says you put in 0 for x. So we're still using my same equation. I'm going to do it over here. Y equals 1.5x minus 9. And if we are wanting to find the y-intercept, we replace the x with a 0. So you're going to put a 0 in right here. Now, that does not mean 1.50, right? 1.5 times x. So y equals 1.5 times 0 minus 9. Well, 1.5 times 0 is 0, so that's gone. So the y-intercept is negative 9. So the y-intercept is negative 9. That means that there is a negative 9 in the y spot. What do you think would be in the x spot? Well, we just said for the x you would put in a 0, so you'd have to put in a 0 right there. So this is the y. Oops, and there shouldn't be 2 dots there. Let me get rid of that. Let's try that one again. Y-intercept. So it's kind of backwards. So if you think about it, the y-intercept has x is 0, the x-intercept has y 0. Please try and keep that straight. Okay? So if I wanted to graph that, if my x-intercept is 6 and my y-intercept is 9, should be able to graph that fairly quickly. So, and I believe they did that on this coordinate plane right here. So they did x-intercept. X-intercept is 6. So on the x-axis, this is just a portion of it, but on the x-axis, they put a dot on 6. Then the y-intercept is negative 9. So they went down to negative 9, put a dot, and then you can just connect them. All right? So let's try the next one down here under got it. And I know you're going to be able to graph it once you find the intercept, so I want you to pause it and try the intercepts. Pause it and try the intercepts. I'm going to clear all this off of here for you. Pause it and find the intercepts. All right, so for A, the x-intercept is 15. X-intercept is 15. Y-intercept, 5. For B, the x-intercept is 2. And the y-intercept is 3. Now, I probably did something up here that might confuse you, so I'm just going to take it off of here really quick. Whenever I say x is equal to 15, I probably shouldn't write that. I should probably say that the x-intercept, see if I can squeeze it in there, the x-intercept is 15 and the y-intercept is 5. I don't want you thinking that the y-coordinate necessarily always I'm putting in a 5 for y. That's not what I mean. The x-intercept is 15, the y-intercept is 5. So x-intercept 15 would be about right here. The y-intercept 5 would be about right here. Draw a line to connect those two. B, x-intercept 2, y-intercept 3, should be able to draw a line. Now, yours, I want you to draw rulers. There's a bucket, draw using rulers. There's a bucket of rulers. Yours would look so much better than my free-handed ones right there. So I want you to use rulers, so please do so. Okay, real quick, moving on. Next, we need to talk about standard form. So far we've had direct variation form, slope-intercept form. Here's yet another form for you to add to your notes. Right here. AX plus BY equals C. That is standard form. AX plus BY equals C. So that is just something, another form for you to know. All right, so we've had direct variation form. If you don't have these, please write these down. Direct variation form, and let's get a pin color that you can see. Direct variation form, y equals AX. Slope intercept form, y equals mx plus b. And now we have standard form, ax plus by equals c. So notice that they all have the y and the x. They're just in different locations. And there may be a different letter in front of the x every time, but that's always the same thing, either the slope or the constant, the rate of change. So don't let those letters fool you. All right. Last one we're just going to talk about here real quick. Malden Middle School wants to make $4,740 from yearbooks. Print yearbooks X cost $60 and digital yearbooks Y cost $15. This can be represented by the equation 60x plus 15y equals 4740. So what does that mean? They want you to be able to find the intercepts. So again, to find the x-intercept, you put in 0 for y, which in other words takes out the y altogether. 60x equals 4070. Divide by 60, you get x is 79. To find the y-intercepts, let x equal 0. So it basically takes out the x. So you got 15y equals 4,740. Divide by 15, you get 316. Now, what does that mean? Who cares? It's yearbooks. Sorry, Miss Pearsall. It's yearbooks. Well, what does that mean? Here's what it means. If you've got your x-intercept 0, that means what if you sold 0 print yearbooks? If you sold 0 print yearbooks, it means they would all be digital yearbooks. So if you sold 0 print, let's see, 0 print would be this one. 0 print, and if you sold all digital, you would have to sell 316 to reach your goal. Well, let's say maybe no one wanted the digital yearbook and you wanted all print yearbooks. So in order to be print yearbooks, which is Y, in order to be all print, you have to put in a 0 if you want just all print. So print all yearbooks, your Y would have to be a 0, which would completely knock those out. So $60 per every one divided by 60, you would have to sell 79 print yearbooks. So that's what they're talking about there. That's a form of using the intercepts in real life. So 79 print yearbooks or 316 digital yearbooks, that's what you've got. All right, just so that way you'll have them on number 1. The x-intercept, 3. The y-intercept, -9. And make sure you are labeling these as intercepts. Number 2, x-intercept, -4. The y-intercept is 2. Down here on number 3, the x-intercept is 48. The y-intercept is 36. Good luck.